Live broadcast, preparing on air, right? Let's see where this goes. All right, so I gave that brief description of fuel economy. Once again, just for this who weren't here yesterday, when you go to purchase a vehicle, whether it's new or used, there will be lots of info they give you. If it's a brand new car, you'll have a sticker. They actually put stickers like this on home appliances too. Has anyone ever seen like a new stove or a new fridge? They'll have these stickers that tells how much energy they use. Same with cars, except the energy a car uses is gas. So it'll tell you how many liters of gas it goes through in 100K. Notice there's two different numbers, right? And if you look close, it says city, highway. Who can just quickly re-explain for people who were here yesterday, why are there two numbers? One for city, one for, why are there two different fuel consumptions? Yeah, I don't know if you heard Selena, but there are different driving patterns. In the city, you're stop, start for all the lights and pedestrians and stop signs. So you actually use more energy in the city. Your car uses more gas. That's one of the reasons for using cruise control too. Like if you're highway driving, you put it on cruise control and it'll just go at that steady rate. That goes through way less gas than if you're one of those people who does this with the gas pedal, right? Speed, slow down, speed, slow down. So that's why there's two different fuel economies, but it's averaged out to have a rounded number. Okay, so fuel economy. We used a cross-multiply technique to calculate fuel economy. And what that was I just quickly explained, and again, I'll just do this so that's on record for even people who were here yesterday. When we have two fractions equal to each other, let me think of two different fractions. Well, everyone knows that, I think, 4 out of 8 is exactly 1/2 of something, right? So how I explained this yesterday is 4 divided by 8 equals 0.5, 1 divided by 2 equals 0.5. But what many people don't know is that when you have a fraction equal to another fraction and they're equivalent fractions, that if I cross the numbers like this, like make an X, these two numbers, the 4 times 8 or 4 times 2 will always equal the 8 times 1. Okay, it's called cross-multiplying fractions. So that means if let's say I don't know, I'm trying to solve for one of the numbers, I have a fraction equal to another fraction, and I'm trying to solve for the missing piece, I can use a cross-multiply method. So once again, anytime you have a fraction equal to another fraction, and you're missing one of the numbers, you can use this technique. So what I do is I cross the numbers. I'm crossing the numbers that I know that I can multiply out. So 8 times 1, and I divide out this number because this guy doesn't have a partner, right? I'm looking for this guy's partner. So he's the number that I divide by, and that will give me 8 times 1 is 8 divided by 2. That always gives you the missing number for cross multiply. Okay, that's the technique we're using. So let's see how that helps us with fuel economy. A car with a full tank of gas traveled 612 kilometers before it needed gas again. If the car took 53.8 liters of gas, find the fuel economy. So you really have to know the definition for fuel economy, that it's the number of liters per 100 kilometers. So they want me to find the fuel economy for the car. I'm looking for the number of liters for 100 kilometers of driving, right? And I do know that this car took 53.8 liters of gas to travel 612 kilometers, okay? So it said, I guess the magic term that I was looking for in this question to know how to approach it or what they were looking for, the Q words for me was the question, right? Find the fuel economy. As soon as I saw fuel economy, I knew I was looking for liters over 100K. So that's the first thing that I wrote down. And then I mean, you could write this down first too. It doesn't matter which fraction you write first. But it did give me the two pieces of info. It gave me the liters and the kilometers that partnered up. So 53.8 liters travels 612 kilometers. I don't know how many liters travel 100 kilometers. That's what I'm looking for. So that's why these fuel economy questions lend you into like a cross multiply technique, because it's quite easy then, right? So these are the two numbers I know that cross each other and meet. So 100 times, maybe I'll use this again. 100 times 53.8, and then this is the number I'm dividing out, right? Divided by 612 should equal my number of liters.
8.79.
Okay, sounds right. $8.79, right? So we would say fuel economy is this car uses 8.79 liters per 100 kilometers. Okay, any questions on that? Okay, well, I'm going to read, yeah, I'm reviewing 7 and 8 because the video recording didn't come through, right? But then I'm going to do 9 and 10. So you can start working on the assignment if you want to start working until I get to 9 and 10. If you want. Okay, next one. Determining a fuel economy again. All right. So you take a test model on a truck. The fuel tank was full when you started. At the beginning of the test drive, the odometer read 109.3. At the end, the odometer read 198.8. You fill up the gas tank at the end and found you used 12.5 liters. So that's how many liters I used. Determine the fuel economy for this truck. Okay, if I'm looking for fuel economy, I'm always looking for the number of liters to go 100 kilometers, right? I'll always know that's not going to change. Fuel economy always involves 100 kilometers. Now I have to figure out how many liters I used. Well, it said I used 12.5 liters, right? And now I just need to know how many kilometers I traveled. And by the way, in cross multiply, if my kilometers are on the bottom in this fraction, they have to be on the bottom in this fraction. If liters are on top here, they're on top here. So how many kilometers did I travel? Okay, let's see. I'm going to have to do some calculation, right? To calculate the number of kilometers traveled, what do I have to do here? What does this odometer mean? Yeah, we talked about this yesterday, right? It's an instrument on your dashboard, right? Odometer keeps track of, of the distance traveled. It's exactly like when you wear those pedometers or a smartwatch and it tells you how many steps you took. It's the same thing. It's just a little dial full of numbers, and every time while your car is moving, you can actually watch the kilometers go up on your odometer. Okay, so let's see. The odometer, when you hopped in your car, it said that you were at 109.3K, so that's how many kilometers in total you've traveled in your car. Then when you got out, it read 198.8, so it's just a subtraction, right? 198.8 subtract 109.3. Here. Thank you. 109.3. It's 89.5, Nicole? Yeah. Mm-hmm. I gotta do it again. Kilometers traveled. Okay, so sometimes you have to dig a little for the numbers. They were nice to us in the first example. They gave us everything. So these are my kilometers, 89.5 kilometers. All right, so it's just the same technique. I multiply the numbers that are diagonal to each other, and then I divide out the leftover. So 100 times 12.5 divided by 89.5. Yeah, so I get 13.966 repeating, right? So 1397. So that's how many liters I would use up. So the fuel economy is, okay, so it would be 13.97 liters per 100 kilometers. All right, if we look at the numbers from example 7 and 8, the car had 8.79 liters fuel economy for every 100 kilometers driven. The truck had 13.97. Which one was better? Which had a better fuel economy? The car, right? It used less. And that makes sense, right? Trucks are usually bigger. The bigger the vehicle and the heavier the vehicle, the more gas it's going to go through. Right? All right, so that brings us up to, I mean, definitely if you weren't here yesterday, look at the other examples as well, and you can go online and get the notes or get them from someone else. Now let's go on to the two that we haven't done yet. They're kind of, I think they're more of summary, so that's good. So let's take a look at example 9. So kind of the same thing we just did, right? You own a car and a truck. Lucky you, right? The car has a fuel economy of 8.7 liters per 100K. The truck has a fuel economy of 15.3, so we're not surprised at that, right? You need to drive to your mom's house, which is a round trip of 430 kilometers. You already know that the car would be cheaper on gas, but you want to take your truck as it is more comfortable. How many liters of gas would be needed by the car for this trip? Okay. What am I going to do? How do I start this question? How many liters of gas? They're not asking me for fuel economy. They gave me the fuel economy, right? So, yeah, so what technique would we use? What would? The same thing, the crisscross. So they gave me 8.7 liters per 100K. That's just a side-by-side way of writing a fraction, right? That's just writing a fraction with a diagonal instead of a proper. So they gave me this, 8.7 liter per 100K, and I mentioned that yesterday. This is sort of, it's not the nicest math way, but that just still shows that per sign is a division symbol. So I'm writing it the proper math way, equals, okay, I'm trying to figure out how many liters of gas would be used by the car, but either way for both car and truck, the distance I have to travel is 430 kilometers, right? Okay, so that's easy, right? I'm just looking for this liters. So same thing. Multiply, divide. Okay, so I get 8.7 times 430 divided by 100 equals 37.41 liters. Now this time, I can just answer the 37.41 liters of gas because they're not asking me for fuel economy. They gave me the fuel economy. So this is liters of gas. All right, we're going to do the same thing for the truck. I'm going to give you a minute to calculate that, and then I'll jump in with mine. What are we expecting, though, a higher or a lower number? Higher, right? So just keep that in mind when you do your problem, that your answer should be higher than 37.41. Okay, what did we get? Yeah, I think I got that too. So I got 14.3 times 430 divided by 100 equals 61.49 liters of gas. Agree? Okay. So for sure we were right. The truck is burning way more gas. If the cost of gas is $1.129 liters, so you can see here, again, like I said, I think there's something else that I can't think of at this moment, but gas is one of the few things that you'll see to more than 2 decimals, like the cost, because in Canada we just use 2 decimals for cents, right? So it's kind of weird to see that, but that's how gas is priced. How much would you save by taking the car instead of the truck? All right, what am I going to do with this $1.129 to answer the question? Multiply it by the liters, right? So if they made how much I'd save, what else do we have to do? By taking the car instead of the truck. So the car takes this many liters, the truck takes this many liters. Yeah, minus, right? There's a couple of different ways you could do it. So I'm going to let you figure out your strategy for come up with an answer, okay? Okay, do I have any numbers for answers? How much gas how much gas, or how much money, sorry, how much money would you save?
I don't know, I got $27.19.
Yeah? $27.19. How many people got that? Okay, I think rounded we got 19 cents. Good. I think there's more than one way to do it. So how did you get it, Selena?
I did 61.49 minus 37.41, which gave me 24.08. And then I took 1.129 times 24.08, and then I got 27.19.
Sort of how I was thinking of it, but
That's not what you were thinking?
that's the same way I was thinking, but there's another way to do it too. So what Selena did is she just said, well, the difference between the number of liters of gas is going to be the extra amount that the person has to pay, right? I could either go through this many liters or this many liters, so the difference is going to be the difference in cost. So she did that, and she got a difference of 24.08 liters more for the truck, right? Ugh. And then she took the difference in the liters, right, that extra liters that the truck will use, and she multiplied it by the cost. And that gave her an answer of 27.19. More than the truck. More that the truck.
Well, when did you save? You saved $27?
Or sorry, yeah. 27 more.
$27.
Either you spend 27, yeah. Never mind, I'll answer the question. My English was really bad there too. Okay, $27 in savings,
Yeah.
right, if you take the car. Was there, I know there's another, at least one other way to do it. Did you do it a different way, Sadie? What did you do? Well, the longer way, maybe not the harder.
Sure. I took the liters that each car
Yeah.
takes and then times that by the price.
I think probably the majority of people might do it that way, hey?
Yeah, to find
How
out.
many people did it that, because it makes sense, it's not the, so you took your 37.41 times the 1.129, right? What'd you get?
42.24.
20,
Sorry, 42.24.
oh, 42.24. Okay, and then you took the truck, right, which was 61.49.
Why, Kim,
Yeah.
why we shouldn't multiply the track for like the amount of 1.129?
That's what we're
That's what I'm doing.
Oh, you're doing that?
Yeah. Okay, so Sadie, what'd you get here?
69.42.
69.42?
Yes.
And then you just subtracted those.
Yeah.
That's really.
the way I did it too.
Yeah, perfect. But what happens? It's the same, right? I just want to encourage you that there's, in every question, there's at least two approaches, sometimes more than that. So it's what makes sense to you. They're both great approaches, right? Hmm?
I got 27.18 and it didn't have a round.
Because you bet you rounded at both, okay? Okay, that's both acceptable. Yeah. Okay, yeah, so see, it's however, are they the same thing? Yeah, you're just calculating the differences in a different way, but you're coming to the same answer. Okay, so perfect, great. So $27 in savings. Now you might say, what might make a person take a truck instead of a car, even if they're going to pay $27 in gas more? Yeah, you might be going to your mom's to move her old couch or bring back some stuff that you want in your place. So there's all sorts of reasons why people would take a truck. Or maybe you're going through rough country, right? And you want to go down dirt roads and a truck would be way safer. Okay, let's take a look at example 10. This is an interesting one because it's actually from an old exam. So Myrtle and Zayden just went on a long trip in their car. They recorded the following info. They traveled a total of 4,150 kilometers. It's a long trip. They used 490 liters of gas, and the total cost of gas for their trip was $588. Now that you know quite a bit about fuel economy, I think, calculate the fuel economy for this trip. So you know what that is. That's finding the number of liters that would travel 100K. Do you have enough info to calculate the fuel economy? If I ask you to calculate fuel economy, what are you really looking for?
How much gas is?
Yeah, how much gas goes with, yeah. Well, no, how much gas it takes for 100 kilometers, right? So you know that you know this number, right? This is the number you don't know, right? This is the liters. So you're always looking for the number of liters for 100 kilometers. Okay, so I'll start you off.
Could you just divide distance by the amount of gas used?
Fuel economy is always defined per 100. You could start that way, and then you have to do a little adjustment. Okay, so you need another fraction, right, Selena?
So we're gonna do,
So what do you need for this fraction? You need liters and kilometers. Do they give you liters and kilometers?
yeah.
Yeah. Yeah, so when they ask you for fuel economy, they're really asking you, well, they want you to state it properly, but you're really solving for the number of liters of gas all the time, right? Because you always know that the bottom is 100K. Okay, so properly stated, fuel economy is 11.81 liters per 100K. Yeah? Okay. Now, I'm not going to say anything for a second. I'm just going to give you a few seconds. Part B was calculate the cost of gas per liter for this trip. It gave you the total cost of all the gas for all the liters, and it gave you the number of liters too. Okay. Anyone want to share an answer with me? Or a technique?
For the last one,
Yeah.
I did 490 divided by 90.
Okay. What'd you get?
I got 0.8.
Okay. Anyone else get something different?
I took the amount of gas that it costs and divided by the liters, and it was 49.75.
So you put cost divided by liters? Yeah. And what did you get?
49.79 per liter.
So you did cost per liter. Try that again, Kelly. Because I did that, but I got a different number.
So I thought it was for the trip that they were using all of.
Yep. So 588, your division, this is right, Sadie, but if we want the cost per liter, that tells you which number should go on top and which on the bottom, right? Cost comes first, liters come second. So cost per liter, if I do 588 divided by 490, I get, so I agree with your process, Kelly, but I got $1.20 per 1 liter. So cost per liter. Did anyone do it in a cross multiply way, in a crisscross way? Do you want to see this cross way too? I don't know. Okay. So it gives you the cost. It gives you the it gives you the number of liters. If you do the crisscross way, it doesn't really matter what you put first, but usually money goes on top. So let's do money. So I have 588 goes on top of the 490. Okay? Now, what was your job? Your job was to find the cost, that's what I didn't know, per liter. What does per liter mean? How many liters do we have? What's 1 liter, right? So I have 1 liter. I just want the cost for 1 liter, right? That's your unknown. So, and you can always do this crisscross method comes in handy, right? To keep everything sorted and in the proper order. So X equals 588 times 1 divided by 490. You're still going to get, the cost is $1.20 per liter. like $1.20 over 1 liter, which is per liter. Okay. So if you're trying to find a unit cost, just remember always keep money on the top because it's cost per whatever you're looking for. All right. So that's it. I think this gives you lots of examples. Like I say, if you weren't here yesterday, you can hop on the blog because all the hard notes are on there. I did ask the class to start the assignment, so I'm going to give you a little time to work. I will also give you tomorrow's class to work on assignment 1, okay, to finish it up. It's quite dense. If everyone finishes it in the middle of class, of course, we'll start something new. But I will give you a work class. We haven't had one for a while, and it's kind of dense, right? And I want you to really grasp this unit.
So it's like number 14.
Yeah, it's a big one, right? Yeah, that's why I got to give you tomorrow's class as well, I think. All right, so get started. Grab someone's notes if you need to. You can grab my booklet if you need to.